Assalamu alaikum students. Today we will be discussing some key concepts and equations related to coefficient of performance for both vapor compression and vapor absorption refrigeration cycles. So let's dive into these equations step by step. As we know that in a heat exchanger, heat rejected by hot fluid is equal to heat absorbed by the cold fluid. Now, if I relate this equation with heat exchangers present in chillers, we come to know that in evaporator, heat rejected by chilled water is equal to heat absorbed by the refrigerant. In the same way, in case of absorber, heat rejected by refrigerant absorbent solution is equal to heat absorbed by the cooling water. Similarly, if I talk about condenser, heat rejected by refrigerant is equal to heat absorbed by the cooling water. In the end, if I talk about generator, heat rejected by heating source is equal to heat absorbed by the refrigerant absorbent solution. For vapor compression refrigeration cycle, since it's a cyclic process, so we can write that energy rejected by refrigerant is equal to energy absorbed by the refrigerant. As discussed previously, that in a heat exchanger, heat energy rejected by hot fluid is equal to heat energy absorbed by cold fluid. So we can convert the above equation for energy conservation as heat absorbed by cooling water in a condenser equal to heat rejected by chilled water in the evaporator plus work done by the compressor. Now for vapor absorption refrigeration cycle, we will apply the same energy conservation equation. Energy rejected by refrigerant equal to energy absorbed by the refrigerant. Now we will convert the above equation and will write heat absorbed by cooling water in condenser plus absorber equal to heat rejected by chilled water in the evaporator plus heat rejected by heating source in the generator. Coefficient of performance is basically a ratio of output upon input. In case of vapor compression refrigeration cycle, coefficient of performance is equal to heat rejected by chilled water in evaporator divided by work done by compressor. While in case of vapor absorption refrigeration cycle, it is equal to heat rejected by chilled water in the evaporator divided by heat rejected by heating source in the generator. So here we have our common expression for coefficient of performance of chillers for both vapor compression refrigeration cycle and vapor absorption refrigeration cycle. It is heat rejected by chilled water in the evaporator divided by the difference between heat absorbed by cooling water in the condenser and heat rejected by chilled water in the evaporator. I hope this video has provided greater clarity on the concept of coefficient of performance for chillers. If you have any questions, please feel free to reach out. I would be delighted to address your queries. Thank you for watching.